Hey guys, welcome back to another Maths Made Easy video. This time we're going to be doing partial fractions, which is a really good core topic to do because it comes up multiple times every single paper, because you use this when you do binomial expansion and when you do integration and differentiation. So whenever you have a question on integration, there might be a part A saying express whatever in terms of partial fractions, same with binomial, etc. So it is one of those core topics that you need to get really good at, in the same way that you need to get good at algebraic division, which again comes back in partial fractions, which is very interesting. But before we get started, again, most people that watch these videos are unsubscribed, so if you do find this video or any of the other content useful, I would really appreciate it if you could hit the subscribe button. If you're interested in tuition or anything else that I offer, then my website is in the description, as well as my email address in case you want to ask any questions that you may have about pretty much anything. I do respond relatively quickly. But without further ado, let's jump straight into what on earth is partial fractions. So when we do partial fractions, you might be wondering what on earth is the point. Well, let me give you an example to try and illustrate what we're doing. So if we have like 2 over x plus 1 plus, let's say 4 over x plus 2, we can combine that in order to express it in terms of as one fraction, which can be very useful. And how do we do that? Well, we make the denominators the same, right? So it times the first one by x plus 2, and then we get this. I promise you there's a reason I'm doing this. And we times the second fraction by x plus 1. And then we'd, expand, simplify, bring it all together, and all of that fun stuff. So here we would have, if I expand and combine, so 2x plus 4x gives me 6x. Then we have 2 times 2 is 4, 4 times 1 is 1, so we have 4 plus 4, which is 8, all over x plus 1 and x plus 2. Now in maths, there's a really core principle whenever we do anything with maths, which is if we do some kind of operation or we do a task, we should be able to undo it. So because I can do an operation, I can add two fractions and combine them together. I should be able to split fractions apart and work out what it looks like. Now if you imagine, if I gave you this fraction and I got rid of this, how could you get to the original two fractions? Well, you know, or at least it's possible, that there were two fractions to start with, which again, if I just show you back what we had before, there were two fractions to start with. And one of them would have x plus 1, and one of them would have x plus 2. Okay. How do we know that? Because we have two separate parts of the denominator here. In terms of what's on the numerator, we have no idea. So we could call them both a and b respectively, because again, we do not know what a and b are. Partial fractions is all about figuring out what a and b are using some very clever algebra and manipulations. Let me give you an example question. So here we get given a fraction, and it has 8 over x minus 1 x plus 3, and it says express in partial fractions. So again, we know that there's going to be two fractions. How do I know there's two? Because there's two brackets in the denominator, one with x minus 1 and one with x plus 3. And as for the numerators, I have no idea. Just like in the first example, we have no idea what they are. So how do we work those out? Well, if I times both sides of this equation by the denominator here to eliminate the fractions, so again I'm going to times by x minus 1, x plus 3, I'm going to do the same thing on the other side. The reason why we're doing this is to eliminate the fractions, so that way I can work out what a and b are. Have a look what happens. Well, this side is just now 8. With this side, well, the x minus 1 will cancel out, and we're left with a x plus 3. And with the other one, again, we'd have the x plus 3 cancelling out, so we have b x minus 1. Now, I know what you're thinking. This has two unknowns, so we can't solve it unless we have multiple expressions. And you are technically right, but there is something we could do. Because we have these brackets here, if you remember when we do quadratics, when we have a double bracket, in order to solve it, we make one bracket equal to 0 and see what the other bracket equals, and then vice versa, right? We can do the same thing here. What if I make this first bracket equal to 0? Well, then that means a goes away, and then I have an equation that just has a b in it. So let's do that. How would I make this bracket equal to 0? I would sub in x equals minus 3, because minus 3 plus 3 is 0. And that would give me a equals this first thing will go to 0, right? Because minus 3 plus 3 is 0. No matter what a is, a times 0 will be 0. And I'm left with b minus 3 minus 1. So in other words, I have 8 is equal to minus 4b, which means minus 2 is equal to b. So in other words, the number on the numerator here is going to be minus 2. Okay, that's pretty useful. I can repeat the exact same process for a. So I now know what b is, so I'm going to rewrite that expression. You don't have to rewrite the expression, but I think it is kind of useful just to see, for the example, what we have. We have minus 2x minus 1. So realistically, I can sub in any value of x. But if I sub in x equals 1, then this whole second part of the equation goes away. So we have x equals 1. What happens? We have 8 equals a, 1 plus 3, and then 0 on the end. So that means 8 is equal to 4a, which means a is equal to 2. So if we were to write out this expression in terms of partial fractions, this is what your final statement would be. It would be 8 over x minus 1, x plus 3 equals a, which is 2, over x minus 1. Then there are two ways to write this. You can write plus minus 2 over x plus 3, but in my opinion the way that it looks better is if I get rid of that and make this a minus overall. And again, if you want to prove that this method works, you could combine these two fractions and see that you do indeed get 8 over x minus 1, x plus 3. And again, if you want a bit of a challenge, try and go back to this question and get back to the original thing that we did. But that's how you would do it in terms of just having numbers on top. Now, as with everything, it does get a bit more complicated. The difference here is we have algebra in the numerator, and this is where a lot of students make mistakes. So I don't think partial fractions is necessarily difficult, but you need a lot of practice to make sure you don't make a mistake in your exam, because it is very, very easy to make a mistake. And the problem is you won't know you've made a mistake, because most people don't check their answers by combining the fractions again to see if they get the question. Which means when you do the part B, when you do binomial expansion or you do integration or both, you just get the wrong answer, and there's no error carried forward in that case because you've made a mistake earlier on. So here, again, the principle stays the same. We have a over x plus 2 plus b over x plus 3. And a and b here probably have something with x in them. They are just going to have numbers, but here we're going to have x on the left-hand side. Again, I'm timesing through by x plus 2, x plus 3 on both sides. There is a reason why I'm writing this out every single time, because there is a partial fraction later on, where if we don't write this out, we may make a mistake. But we will get an answer of x minus 1 equals, again, the x plus 2 will cancel for a, so a, x plus 3, plus b, and this would be x plus 2. Once again, all we want to do is eliminate one value at a time, and it doesn't really matter which way around you do it. Let's do the first one first, right? So let's sub in x equals minus 3. Minus 3 because minus 3 plus 3 will give us 0, which means a, the first term, first part of the expression, will go to 0. But again, we have an x on the left-hand side now. You have to include that. And we get b minus 3 plus 2. So we have minus 4 equals minus 1b. So minus b, which means b is equal to 4. Again, we could replace the b here with a 4 now, but there isn't too much need in doing that because we're just going to eliminate it by subbing in x equals minus 2 anyway. And we get minus 2 minus 1 equals a minus 2 plus 3. So we get minus 3 equals a. There you go, nice and quick. So that means, again, as our final answer, we would write this, x plus 3 equals a, which is minus 3. Again, you could swap these around if you really wanted to. So personally, I think it looks better to have the negative on the second one, but just to not confuse anyone, you would have something along the lines of this. And again, if you swapped these two around, you would also get the same thing. Because remember, they don't really care about the order, they care about you having the correct fractions. These two would add to give this, but again, if you had 4 over x plus 3 minus 3 over x plus 2, that is also acceptable. I put this question in here not necessarily because it's harder than the others, but just to show you that you may have to do something before partial fractions, which in this case is factorize. So you would have to write this as 4x plus 6. You do not have to factorize the numerator, although be my guest if you want to, but you would have to factorize this using difference of two squares, because otherwise we do not know what the fractions would look like. The common mistake that I see here is some students writing this. Remember, when we combine fractions, when we add them together, we have to times them by each other to make the same. So in this case, we'd have to times it by minus 9, and this side times by x squared, which is not the same as having x squared minus 9. Instead, it would be minus 9x squared. So you need to be really careful that your denominator is a product. So in other words, it's two things multiplying each other before you do something like that. So yeah, don't do that. And then again, you follow the exact same process. Times through by x minus 3x plus 3 to get 4x plus 6 equals a x plus 3 plus b x minus 3. And once again, do the exact same thing. We're going to sub in x equals minus 3 and 3. Let's just do x equals 3 first. Switch it up, right? So we have 4 times 3 plus 6 equals, so here it would be 3 plus 3 is 6, so it would be 6a. So 4 times 3 is 12 plus 6 is 18, so 18 equals 6a, which means a is just equal to 3, and then sub in x equals minus 3, and we get 4 minus 3 plus 6 equals, so a goes to 0, but b becomes minus 3 minus 3, which is minus 6, so minus 6b. So that's 4 times minus 3 is minus 12, add 6 is minus 6. So we get 1 is equal to b. So our final expression is going to be 3 over x minus 3 plus 1 over x plus 3. Nice and simple like that. When we get to the next one, you're going to see that you may have to also do something else. For this one, another common thing that I see is people trying to factorize the top, which I do get because maybe it factorizes with the bottom. If you want to quickly check that, you can use a calculator to actually factorize. So I've shown you how to solve using a calculator before, but that also actually provides the factorized form. So in this case, yeah, so I can see that you couldn't factorize this anyway, so we don't need to worry. There you go, nice and easy. But maybe later on I'll be able to show you one where you can factorize. So here, how many fractions are we going to have? Well, how many products do we have on the bottom? We have 3. So here we will have a over x plus 1 plus b over x plus 2 plus c over x minus 6. It's the same principle. Now, what do we times by? We times by the entire denominator, both sides. And once again, we'll get something like this. We get 2x squared minus 6x plus 20. Now again, some people like to write out the whole thing, so write a times all of this over x plus 1. But what I like to look at is, if I have a times all of this, the only thing that will cancel is the x plus 1 and the x plus 1. So that becomes a x plus 2 x minus 6. And then b, the only thing that will cancel is the x plus 2, so we have x plus 1 x minus 6. And again with the c, we have plus c, and anything that cancels the x minus 6. So this looks a lot more complicated, but have a look. All you're going to do is pick any bracket to make equal to 0. So let's just pick the first bracket. And look what happens if I sub in x equals minus 2. Well, obviously we have this bracket goes to 0, but also this bracket here, which leaves me with just b. So as you can see, it does help, and it's no more complicated really, because you're still just eliminating one bracket at a time. And because all three of them have different combinations of brackets, you can still do this. Now this is where I recommend to students use a calculator to work out both sides. Because again, doing this in your head, you will make mistakes at some point, especially when you consider that this may only be a 2 or 3 mark question at the beginning of part A. So I would write the full thing subbed in, and then I would use my calculator to work it out. Again, I know A is going to go to 0, I know C is going to go to 0. It's just B that we're looking at. So B with -2 plus 1, -2 minus 6. So, see already I forgot the squared over there, that was quick. So, using our calculator, we have 2 minus 2 squared minus 6 minus 2 plus 20. So that's 40. Again, no risks at all. The reason why I mention this is I have some very, very intelligent students, but they do make mistakes. I make mistakes if I don't write the whole thing. And literally I'm just writing the second bracket that, whoops. The reason why I'm writing just the second bracket is when I type this in, it will give me the coefficient of B. So B is 8, so it's 8B. Divide both sides by 8 and you get 5. So that's 1. And again, I do like to highlight these because in a mark scheme, they will be looking for A, B and C. And you may not have got it in the same order as the mark scheme. Maybe they work out A, then B, then C. Maybe they work C, then A, then B. Whatever. So highlighting it makes the examiner's life easy. I know you may not like the examiner, but at the end of the day, the easier you make their lives, the more likely they are to give you marks. So the next one, I'm just going to check the next bracket, which is x minus 6. So to make that equal to 0, I'm going to sub in x equals 6. So again, we have 2, 6 squared, whoops, minus 6 times 6 plus 20 equals the first and the second term are going to go to 0, so it's just the last one that's left, which is C. So 6 plus 1, 6 plus 2. And again, no risks because there's no need to risk anything, right? 2, 6. And again, you can probably type this faster than me. Since I'm using a computer, it's a little bit trickier to type everything in. So that's 56 equals, and again, we have the brackets on the other side. If you're perhaps a little bit smarter, you may have just done the brackets on the right first because I'd already written it for the previous term. Yeah, okay, 56C. So C is just equal to 1. So again, a little bit longer, but as you can see, the actual process is no different. And then lastly, we're going to eliminate, in fact, we want B, right? No, we want A. So I'm going to eliminate B by just subbing in x equals minus 1. So we get 2, wait, is it minus 1? Yeah, it's minus 1. Just see the paranoia creeping in. And that plus 20 equals, and then it should be A that's left. Minus 1 plus 2. Minus 1 minus 6. Yep. So again, even though this might be trivial, just use a calculator. There's no sense in getting something wrong for no reason. And again, when you have your mock exams and things like that, I know some of you doing the exams now, you're doing some exams in school, which maybe can adjust your predicted grades. So, well, depending on when this comes out, actually, it might be a bit too late. Actually, no, it'd definitely be too late. That shows you how far in advance I'm actually recording some of these. But anyone watching this in the future, if you're trying to adjust your predicted grades in year 13, which some schools let you do by doing well in tests, you want to make sure you're not making stupid mistakes, because stupid mistakes are stupid, right? So if you're doing all the hard work, you want to get the right answer at the end. And then again, right at the end, I rewrite this with all of the new values. So I would write minus 4 over x plus 1, plus 5 over x plus 2, plus 1 over x minus 6, just to make it super clear that I know what I'm doing. You may well be wondering why I've put in a question that looks fairly similar, and it's because of this bad boy over here. So, it is not uncommon for a student to write this. Oh, what am I doing? Oh my god. Okay, it's very uncommon for a student to write that because that's completely wrong. Because that's the product, right? Now, I actually agree with you that could work. It could be this. If I have two things that are adding together, where one is 1 over x minus 1 squared, I would get a denominator that looks like this. But we do not know if there isn't just one that looks like that. That is a possibility. I'm not saying it's guaranteed, but it is possible for it to look like this. Now, in questions like this, it is not uncommon to get the c term equaling 0, because this fraction is not guaranteed. Because again, if I add another fraction that has a denominator of x minus 1, when I times this all together, I will still get a denominator of x plus 4, x minus 1 squared. But again, I get that without this as well. So I get it without and I get it with. So this is like when we have the constant of integration term when we did integration. It's there just in case there is another term that we don't know about. And the good news is, when we do our process, we will find out if c is equal to 0 or not. So just to be clear, a and b will always be non-zero integers. Actually, not integers, non-zero numbers. But c can be 0. As I've just proven to you, if I get rid of this, this adds to give a denominator of x plus 4, x minus 1 squared. But so does this, where we have another fraction of x minus 1. So you have to include this because c might be 0 or it might not be, whereas a and b will not be 0. So let's get to it. Once again, we times through by x plus 4, x minus 1 squared. This is where writing it might be useful because some people make mistakes here, which I completely understand, I completely sympathise. But of course, we need to eliminate all of our mistakes before our exam so we don't lose stupid marks. So here, the x plus 4 is going to cancel, but we're left with x minus 1 squared. Here, the x minus 1 squared cancels, but the x plus 4 stays. And with c, this is where it's a bit more interesting. One of the x minus 1s cancels, but we still have an x minus 1 and x plus 4. And let's follow the same pattern. If you're noticing that we're going to run into, not an issue, but we're going to run into something different, well done. But again, do not worry about that yet. Again, I like to start with from left to right, like I'm reading a book. That's just my personal preference. I'm going to sub in x equals 1, because that eliminates a. It will also eliminate c. So we get 9 times 1 minus 14 equals, this goes away, we're just left with b. Again, I would use a calculator normally. Should we use a calculator just to really illustrate my point? Like even though, see, minus 5. Just so I'm being consistent with you guys. 1 plus 4, okay, I'm not going to stoop that low. That should be 4, no, I'm joking, 5. Which means minus 1 is equal to b. Wonderful. The next bracket is x plus 4. Don't know why I missed that for a second. So I'm going to sub in x equals minus 4. And we get 9 minus 4 minus 14. Again, this is where I'll definitely use a calculator. And b and c will cancel, so we get a minus 4 minus 1 squared. Do not forget the squared. So here I'm going to change that to a minus 4 minus 50. Cool. That should be 25, but again, just to prove that I'm not a liar, and by that I mean that you should do this, I do it almost every time. You can ask, well, you can ask the students at the school I teach at, and that gives me minus 2 equals a. So you may have spotted the issue now, right? There is nothing I can sub in that will eliminate a and b, but leave c intact. But the thing is, I don't care. Because I know what a is, and I know what b is. So with c, the really nice thing is you can sub in any number you like, because there's only one unknown. So which number to sub in? Personally, honestly, sub in something that makes it easy, right? For me, I like to sub in x equals 0. Because most of the time, not all of the time, I'll admit that, but most of the time, it does give something that's reasonably easy. So if I sub in x equals 0, I can see that the 9x will disappear. Now imagine it was a quadratic, right? We have 2x squared minus 9x minus 14. That all goes to 0 except the minus 14. So personally, I like that. Then a is equal to negative 2. So I'm going to put negative 2 there. Then 0 minus 1 squared. Then b is equal to negative 1. So we have minus, I'm not going to put the 1 because there's no point, 0 plus 4. So we have 4. So even this, you can actually kind of get rid of the... Oh, for crying out loud. Thanks, Microsoft. You can even get rid of the 0 because there's no sense in putting it. Then you have c times 4 times minus 1. So you have minus 4c. So for me personally, I think that that's a nice way to do it. So what would I do here? Well, you could work this all out, or you could move it over to one side. Like, you do whatever you want. But either way, minus 1 squared is 1 times minus 2 is minus 2. Minus another 4 will be minus 6. But again, just to prove that I'm not telling porcupines, we could even, careful, sub in these numbers ourselves on a calculator just to make sure we're not doing anything stupid. Yeah, minus 6 minus 4c, I don't know why I was staring at it for so long. Add 6 to both sides, we get negative 8 equals negative 4c. So in this case, c was not equal to 0. But remember what I said. C might equal to 0. Do not panic. C can equal to 0. Yeah, so then I would again rewrite this. So it'd be minus x over x plus 4 and, minus 2 over x plus 4 minus 1 over x minus 1 squared plus 2 over x minus 1 gives you that. Wonderful. The next two questions deal with something that happens that's a little bit interesting. And when I say interesting, I mean not fun at all. Not fun at all. Not interesting at all. Which is, well, I mean, have a think. What is different about this? If you answered that it's an improper fraction, you would be 100% correct. So why is that a big deal? Well, it's a big deal because, now the question is which way around should I tell you this? Because I'm going to have an integer, or just a number, plus, b over some bracket, plus c over some bracket. Because when I work this out, if I were to do division, it would actually fit in a certain number of times. Right? So it would actually go into this however many times. So, how do we work this out? Well, there's a few ways. The first thing I would do is probably just factorize the bottom anyway. That's to work out what the fractions would be. My brain stopped working. So it needs to times to negative 5, add to 4, so x plus 5, x minus 1. So that means these brackets here are x plus 5 and x minus 1. It doesn't actually matter which way around you write them. But now, in order to find out a, there are two things we could do. The first one is we could do the normal method, right? Technically speaking. The second thing we could do is we could actually do algebraic division in order to work out what a is, because that would just be the amount that you can actually go in by, if that makes sense. So, if we do division, x squared plus 4x minus 5, then we have x squared plus 2x plus 9. You divide by the first thing, so that gives me 1. Then we times by all of this, we get x squared plus 4x minus 5. And we subtract. So 0, we get minus 2x. 9 minus 5 means add, so plus 14. So this whole thing here, when we split it up, so I'm actually going to delete that for a second. It becomes 1 plus minus 2x plus 14 over our two brackets, which is x plus 5, x minus 1. Where I got those brackets from, because I factorized it over here. And then this is essentially what we're doing partial fractions on. So two methods. One is you could do it the normal way, except it's going to be a lot longer and a lot more tedious, or you can quickly do this and then separate this into partial fractions, which is a lot easier. So minus 2x plus 14 over x plus 5, x minus 1 equals, I can call it b and c if you want, because we already have a from the first thing. I don't mind doing that. And then again, we can do the exact same thing we've done a billion times before now, equals b x minus 1 plus c x plus 5. And look how this is a really nice partial fractions. I can sub in 1 and eliminate something. So we have minus 2 times 1 plus 14 equals c 1 plus 5. So minus 2 plus 14 is 12 equals 6c, which means c is just equal to 2. And sub in x equals minus 5 in order to do the other one. Minus 2 minus 5 plus 14 equals b minus 5 minus 1. So minus 2 times minus 5 is 10. 10 plus 14 is 24 equals negative 6b. So then b is just equal to minus 4. So our full answer is, oh, I made a parallelogram, is when we equal this, it equals 1 minus 4 over x plus 5 plus 2 over x minus 1. Like that. So again, not too bad. And again, you can imagine now when you integrate this, well, I guess you don't really know integration yet, or you use binomial expansion, but you may not know binomial expansion yet, this becomes so much easier than trying to integrate, differentiate. Actually, no, differentiation is not too bad, but integrate or binomially expand this, that's hard. This is easy peasy lemon squeezy. So it's just infinitely better. It's way better. One other thing to know about this as well is how to tell if it's improper. If the power of x in the numerator is the same, so if the power of x in the numerator and denominator is equal or greater than, then it's improper. Whoops. Then it is improper. I just realised I know I've started a sentence with then, which is very illegal. Good thing I'm not an English teacher, because that would be dreadful. So for example, if I had like x cubed plus 2x squared plus 4x plus 7 over x squared minus 1, for example, this is improper. Most people are fine with it when the power of x is bigger in the numerator, but keep in mind, even when it's the same, you technically should do algebraic division in order to turn it into, well, basically a normal fraction, right? We have 1 and then an additional fraction. But yeah, do keep in mind that a here could even be bigger than this. It could be something like, so in this case here, you can probably see that when you do division, you're going to get an x term and you're going to get a constant. So a would be x plus c, or x plus 3. And then you do partial fractions with the rest of it. So hopefully that makes a bit more sense. With partial fractions, if you do need any extra like questions or anything like that, if you don't know where to find any, then I would recommend just emailing me, letting me know that you need some help. Or if maybe I'll make a video someday about like all of the different resources that I have, because there are thousands of questions out there. Like, and I'm not even exaggerating when I say thousands. I have worksheets that have hundreds all by myself, but then you can also look at other exam boards. And for the most part, partial fractions in every exam board is exactly the same, because it's partial fractions, it's maths. Same way that factorising quadratics is the same, no matter what exam board you use, because it's factorising quadratics. So even if you went to like an American high school website and they had factorising quadratics, they do it in the exact same way, because it's a common method. But again, if you did find that useful, then please consider subscribing. Again, the website and my emails are in the description in case you want to ask any questions or you're interested in tuition or something along those lines. But without further ado, I will leave you to enjoy the rest of your day or weekend or whenever you're watching this, and I'll see you in the next one.